Hey everyone, welcome back to MiviHub.com. Hey everyone, welcome back to another exciting tutorial on CODESYS. In this video, we're going to dive deep into creating a custom library in CODESYS. Whether you're an automation engineer, a PLC programmer, or someone looking to enhance your skills, understanding how to create and use custom libraries can make your work much more efficient. By the end of this tutorial, you'll know exactly how to set up a new library project, define functions, create reusable components, and generate a final library that can be used in other CODESYS projects. Plus, I'll be sharing some hidden tips along the way that will make your experience smoother. So let's jump right in. The first step in creating a library is to set up a new project in CODESYS. Open CODESYS, and in the Start page, click on File, New Project. Now, you will see a Category section on the left side. Since we are creating a library, we need to select Libraries from the list. From the available templates, choose Empty Library. Next, provide a meaningful name for your project. This will be the name of your library. Also, choose a location on your computer where you want to save this project. Once everything is set, click OK to proceed. At this point, the project will open, and you'll see different sections in the workspace. On the left-hand side, there is a Devices tree, which typically displays connected hardware and configurations. However, in a library project, you won't see any physical devices. Instead, we will be focusing on POUs, Program Organization Units, and other elements that define our library. One thing you might notice is that the POUs, Program Organization Units panel is missing from the project view. POUs are essential because they contain the logic and functions that will be part of the library. If you don't see POUs on the left-hand side, don't worry. Here's how to enable it. Go to the View menu at the top and select POUs. This will make the POU section visible in your project. Now that we have our workspace set up, it's time to move on to defining our project information. Before we start adding functions and variables, let's first define some important details about our library. In the Project Information tab, you'll find various fields where you can enter details such as company name, the name of your organization or developer name, title, a brief description of what this library is about, library version. Every time you make an update, you can change the version number. Default namespace placeholder. This helps in organizing functions within the library. Author. Your name or the name of the developer creating the library. Description. A short explanation of what this library does. One important field here is the placeholder name. This determines how the library will appear when it is imported into other projects. So make sure to give it a relevant name. Once all the details are filled in, we are ready to create functions and variables for our library. Now let's move on to creating some variables that our library will use. These variables will be stored inside a data types folder. Data types are essential because they define how information is stored, processed, and handled within the library. This helps ensure that values are used correctly and efficiently in our functions and programs. To begin, we will create an integer variable that will be used in our library. Here's how we do it. First, locate the data types folder in your project. If it doesn't exist, you can create it by right-clicking on your project name and selecting Add New Folder. Once the folder is available, right-click on it and choose Add Object, then select POU, Program Organization Unit. A window will appear asking for a name and settings for this new function. Let's name it Input1 Int Type. This name should clearly indicate what the function does. Now in the Function Return Type drop-down menu, select UIInt Unsigned Integer. This means that this function will return an unsigned integer value. For the implementation language, we will use Function Block Diagram, FBD. This is a graphical programming method that allows us to visually design our logic. Once you've set all these options, click Add to create the function. Now that we have created our function, the next step is to make it externally accessible. This is important because we want other programs and functions to be able to use this function when they include our library. To do this, right-click on Input One Int Type and select Properties. A new window will appear. Navigate to the Build tab, where you will find an option called External Implementation. Enable this option by checking the box. This tells CODESYS that this function should be available for external use when our library is imported into another project. Once you've enabled external implementation, click Apply and Close to save the changes. Now, if you check the function in the project tree, you'll notice that it now has an indication that it's externally accessible. That's it. You've successfully created an integer function and made it available for external use. Next, we will repeat a similar process for creating additional variables and functions in our library. Now let's add an enumerated data type to our project. But first, what exactly is an enumeration enum? Enums are incredibly useful when we need to define a set of predefined values that represent different states or conditions. Think of it like defining labels for numbers, so that instead of remembering specific values, we can work with meaningful names. For example, if you're working with a PLC that has different operational statuses, like OK, error, or warning, an enum makes it much easier to manage these states in your program. Adding an enum to our project. To create an enum, the first step is to organize our project properly by creating a dedicated folder for it. In the project tree, right-click on the demo library project and select Add New Folder. Name this new folder enum functions. This will help keep our project structured and make it easy to find our enum later. Now that we have a place to store our enum, let's create one. Right-click on the enum functions folder and select Add Object Data Unit Type. A window will pop up asking for the type of data unit we want to create. Select Enumeration and give it a meaningful name. In this case, let's name it PLC Status. Click OK and the enum editor will open. Defining enum values. With the enum editor open, we can now define the different states our enum will represent. Let's say we want to create an enum for PLC status indicators. We can define the states like this: OK = 1 error, 2 warning, 3. Each state has an assigned numeric value, but instead of remembering numbers, we can now simply use OK, error, or warning in our code. This improves readability and makes the program much easier to maintain. Making the enum externally accessible. If we want to use this enum outside our library, we need to mark it as externally accessible. To do this, right-click on PLC Status and select Properties. Navigate to the Build tab. Enable the External Implementation checkbox. Click Apply and Close. Once this is done, our enum is ready to be used in other functions, and it can also be referenced in external projects that import this library. By using enums in CODESYS, we can create more structured, readable, and maintainable code. This approach ensures that when working with different machine states or system conditions, we always use descriptive labels instead of just numbers, reducing the chance of errors and making troubleshooting much easier. Generating runtime system configuration files in CODESYS. Before we finalize our library, there's one last critical step: generating runtime system configuration files. These files define how our library functions will be compiled and integrated into the CODESYS runtime environment. Without them, our library won't function properly when installed in another project. When we create a custom library in CODESYS, we are essentially writing a set of functions that other users or projects can use. However, for these functions to be recognized and executed correctly, CODESYS needs additional supporting files that describe the library structure, interfaces, and function implementations. That's exactly what the runtime files do. They ensure our library compiles correctly and is ready for deployment. Generating runtime files. Now let's walk through the process of generating these essential files. First, navigate to the Build menu at the top of the CODESYS interface. This menu contains various options for compiling, debugging, and managing our project. From the Build menu, select Generate Runtime Files. This tells CODESYS to prepare the necessary system files that will allow our library to function properly in different environments. Next, choose an output directory. This is where the generated files will be stored. You can select a location based on your project's structure, or choose a folder where you typically store compiled libraries. Now let's select the correct file types. In the File Options section, we need to enable M4 interface file. This file serves as an interface description for our library. It helps CODESYS understand how functions, variables, and data types are structured. C stub files. These files contain low-level code that acts as a bridge between the CODESYS runtime and our library functions. They are crucial for ensuring that our library functions correctly when used in another project. Once everything is set up, click OK. CODESYS will now generate the necessary runtime system files. At this point, our library is almost complete. These runtime files are what make it possible to install and use our custom library in different CODESYS projects. Without them, our functions wouldn't be recognized, and external projects wouldn't be able to access the library properly. By following these steps, we ensure that our library is fully compiled, structured correctly, and ready for deployment in any automation project. Now we are ready to create and install the final library. Click on File, Save Project, then click Install in Library Manager. CODESYS will now compile everything and create the library file. Congratulations! You have successfully created a custom CODESYS library. To confirm that everything is working as expected, we need to check the generated files. Navigate to the project location on your system and open the file named demolibrary.c. This file contains all the functions that CODESYS has automatically generated based on our configurations. If you see all the expected functions inside this file, it means the library has been successfully compiled and is ready for use. Now that we have successfully created and installed the library, let's verify that everything is working correctly. This step ensures that all the functions, enumerations, and data types we created are properly integrated and accessible in a new CODESYS project. Adding the library to a new project. To test our custom library, we will create a new CODESYS project and add the library to it. Open CODESYS and create a new project. Go to the Library Manager section, click on Add Library, and select the newly created library from the list. Locating the library file. After installation, the compiled library file will be available in the Miscellaneous section of the Library Manager. This is where all user-defined libraries are stored. Go to Library Manager and check under the Miscellaneous section. You should see your custom library listed there. Checking the functions and enums. Once the library is added, we need to verify that all the functions, enumerations, and other elements appear correctly. Expand the library in the Library Manager and check if all the functions and enums are listed. If everything appears as expected, it means the library has been successfully compiled and installed. You can now use it in your CODESYS projects, just like any other standard library. Congratulations! You have successfully built, installed, and verified a custom CODESYS library. And that's it. Now you know how to create, configure, and use your own custom library in CODESYS. Before we wrap up, let's explore some powerful hidden features that can take your CODESYS library to the next level. These pro tips will help you secure your library, make it more user-friendly, and improve documentation. Secret number 1, password protect your library. If you want to prevent unauthorized modifications to your library, you can add a password protection layer. This ensures that only authorized users can edit the library's code. Go to Library Properties, find the Protection tab, enable password protection, and set a secure password. Now, whenever someone tries to modify the library, they will need to enter the password. This is especially useful if you're distributing the library to multiple users and want to protect your intellectual property. If this tutorial helped you, make sure to like, subscribe, and hit the notification bell so you won't miss future videos. Thanks for watching, and I'll see you